Hello. Today we're going to look into a numerical on histogram equalization. Last time I taught you how to implement histogram equalization in OpenCV in Python, but this time we'll look into the mathematics of it. So we say that we have an image with pixel values from 0 to 7, and this is how our image looks like. So we have few pixels which have values 0, few 1, few 2, and ranging to 7. So how do we go about it? It's very simple and it's like systematic, so you can easily do it. So we write first of all the all pixel values we have, that is 0, 1, 2, 3 to 7. The next part is writing the frequency in the original image. So let's count the number of zeros we have. Okay, we have around 5. Number of ones we have are 3. Number of twos are 6. Then 4. Then 4 again. You can do it on your own. I'm just completing it up. 4, 4, and again 6. Okay, so now we have the frequencies. Now we need to calculate the cumulative frequency. So what cumulative frequency does is it keeps on adding frequencies of all the previous pixels it had. So first for 0 we have 5. But for 1 now we'll have 5 plus 3, that is 8. For 2 we'll have 8 plus 6, that is 14. Then again 4 plus 14 is 18. Then 22. Then 26. Then 30. Then 36 again. Okay, this makes sense because 36 are the total number of pixels we have, right? Now let's normalize it. What normalizing is dividing it by the maximum frequency we have, that is 36 here, right? So we'll divide 5 by 36, then 8 by 36, then 14 by 36, and so on. Let me just complete it up. You can forward if you want. So now, the final step. We need to calculate the new pixel now. It's very simple. We just need to multiply the normalized frequency into the max pixel value we have, that is 7. So once we multiply 7 here, we get a value approximate to 0.97. That is equal to 1. Let's look at the next things. So 7 into 8 by 36, which is around 1.5, which is approximately equal to 2. Then this value is 2.7, which is 3. Then 3.5, which is 4. Now, see, in the fourth one, our value comes down to 4.2, which exactly means like 4, right? So it means that the 4, which was the original pixel value, is not getting changed to anything else. It's still 4. And similarly, this happens for 5, 6, and 7 too. So once we have the new pixel values, let's exactly see what has happened. So we now see that the original pixel value, which was 0, is now 1. And 1 is now 2. 2 is now 3. 3 is now 4. But after 4, everything is the same. That is 4 is 4, 5 is 5, 6 is 6, 7 is 7. Let's replace all the new values to the original values. And we see that what we have is something similar to this. This is the new image which we have. So now you know the mathematics behind histogram equalization. If you want to know how to do it in OpenCV, I have a link in the description box below. Thank you for watching. I hope you understood it. We'll be back next week with more videos. Thank you. Robometrics.